Good evening, guys. Welcome to Videos Online Academy Tutorial. Thanks for watching our videos online. Please, if you have not yet subscribed to the channel, please do well to press the subscribe button and the notification bell in order to see all of our educative videos online. Thanks once again for watching us. Please remember to share these videos with your friends, families, relatives, wards, and colleagues at home. Thank you and God bless you. Amen. Today we are going to be considering a topic called what? Alternating current under the subject physics. What is alternating current? An alternating current is a current with sinusoidally varying voltage and current. Unlike what? Unlike direct current, in whereby we have a steady current with what? Which does not change with time. A direct current is a current or a steady current which does not change with what? With time. But when we're talking about an alternating current is a current with sinusoidal what? Varying voltage and what? Current. So if I want to draw it graphically or represent it graphically, I will write what? I will have my current or my voltage. Yeah, I have both my current, which is what? Voltage and what? Current. Now, if I have my what? My graph of V or Y against what? T, the voltage varies sinusoidally. It varies sinusoidally. Why? The what? The current as well. If I like to have current here. So why my current as well also varies what? So the what? Sinusoidally. So this is an alternating current. An alternating current is the current with sinusoidally what? Varying voltage and what? And current. And this because this has a repetitive what? Pattern. You can see it has a repetitive pattern in form of what? In form of sine graph. We use what? We use simple harmonic what? Motion to what? Determine what? The flow of energy in what? In the circuit. So when you use what? Phasor, which is an instrument used in measuring simple harmonic motion of an object, and now we are considering what? The simple harmonic motion of current flowing in an AC what? In an AC circuit. When you use phasor to what? To determine what? The current which is flowing in a constant velocity. Now, when you consider what? A source of what? EMF of what? AC what? When you consider what? An AC source of what? EMF, e.g. coil. And consider what? An AC source of EMF, e.g. what? A coil moving with a constant angular what? Velocity. With a constant angular velocity, which make it to repeat the same pattern with a constant angular what? Velocity in a magnetic field. In a magnetic field. And when you consider this in a magnetic what? Field, can be determined now. The AC current flowing such an object called coil with a constant angular velocity can be determined using what? Phasor, which is something like this. Now, when you have what? Graphically now, you have a body moving with a constant velocity in a what? In an anti-clockwise movement with W, having what? Having a current of what? I, and what? Making an angle of what? W what? T. So by using what? By using what? Pythagoras theorem, we determine that this is I, which is what? This is I, which is called instantaneous what? Current, is given as what? I naught, which is the peak sine what? Cos WT. When you look at what this is I, this place will be what? Opposite, and this one will be what? Adjacent. When you use adjacent over what? Hypotenuse, you are going to create I, which is called the instantaneous what? I is known as what? Instantaneous current. While I naught is what is known as the maximum what? Current, the maximum current, or called the what? The peak what? The peak current. Also, you can also call it what? An amplitude what? Current or current amplitude. So meaning that the AC current flowing through an AC circuit can be what? At a point, at an instant or at a point in a circuit is given as what? I equals I naught cos what? W2. So also the voltage can also be what? Can also be expressed as what? The voltage of an AC circuit. The voltage, AC voltage, can also be described. Can be described as what? As V equal to V naught sine W what? T cos what? W2, right? Plus W T. Also, can also be what? The voltage can also be what? Described as this. So once again, an AC circuit or an AC current is a current with sinusoidally, as you can see, sinusoidally varying what? Voltage and current. And one of the advantages of what? Of AC current is that AC current has high voltage, which enable it to be suitable for what? For long distance transfer of what? Of power. Now, because of the high voltage of an AC current, it is useful for long distance transfer of what? Of power. Now, when you are doing what? A long distance power transmission, we use AC current to what? To transfer power for a long distance, because we need to avoid power loss as the what? As the current travels through a long what? Distance. This is the reason why what? This is the reason why what? Alternating current is used to supply every ohms, and alternating current is used as a source of power what? Transmission to every homes and industries. And step up transformer and step down transformer is used to what? To lower the voltage and to increase the voltage for what? For suitable use. So that's that about that. The I can be represented as what? I equal to I naught cos theta, and the voltage can be represented as what? V equal to V naught what? Cos W what? T. Now another thing that you need to know that is that for what? Sinusoidal what? Sinusoidal current on AC circuit. Sinusoidal current on AC circuit. Root mean square. The root mean square. For sinusoidal what? Current, the root mean square. The root mean square, known as the root mean square current, denoted as what? I M S, is directly proportional to the what? To the current amplitude. That is the maximum current what? The maximum current, that is the current amplitude, which is given as what? Peak what? The peak of the current, that is I naught over what? Root what? 2. So knowing that what? We have I root mean square equal to what? I naught, which is the peak of the current, all over root 2. So also we have what? For voltage root mean square is equal to what? V naught, which is the peak current or maximum current, all over what? All over 2. Please note that. You know that for sinusoidal what? Current over AC circuit, the root mean square is directly proportional to the what? To the maximum what? To the maximum current, which is given as root mean square current is equal to I naught over root 2, and voltage root mean square is equal to V naught over what? Over root 2. So that's that about what? The definition and the description of the current in an AC circuit, and the difference between that of a current in AC circuit and the direct what? Current in what? In a circuit. Now the voltage and the current in an AC what? Circuit. The voltage and current in AC circuit. Now the voltage and current in an AC circuit, the current, as you know, that the current is given as what? I naught cos what? W what? T. And voltage so is what? The voltage and current are not in the same phase in what? In an AC circuit. Note that what? The current and voltage in an AC what? An AC circuit are not in the same what? Phase. So if I equals I naught cos what? W T, the V is equal to V naught cos what? W T plus what? Phase angle. That's the difference between what? The phase of voltage and the current. And how do we determine this? Is when you draw what? The sinusoidal what? Graph of what? Of the what? Of the voltage. The voltage look like this. We have the voltage with time. This is voltage. We have what? When you trace this one, and this is the what? The amplitude of the voltage. The amplitude of the voltage. And when you draw of current, we have something like this. We have now when you look at it like this now, you can see that the what? The current starts from this is the amplitude of the what? Of the current. This is the amplitude of the current here. So we have what? Current amplitude here. So now they are not in the same phase because this one has started before what this one starts. So now, so from here now we said that what I and what I and V are not in the same phase. The AC voltage is not in the same phase with what? With AC what? Current. Note that what? AC what? Note that AC what? Voltage is not in the same what? Is not in the same phase. Note that what? AC voltage is not in the same phase with what? AC what? Circuit. And the difference is what? V equal to V naught cos WT plus what? Alpha. So this is the phase difference. This is phase difference, which is what? Alpha. So as you can see in the sinusoidal graph, that the voltage and the current are not in the same phase. And this is what brought us to what? To what? To resistor and what? And reactance in circuit. The resistance and reactance, the resistance and reactance in AC what? Circuit. Now before we continue, before we talk about what? The AC what? The AC, the reactance, before we talk about the resistance and the reactance in AC what? Circuit. The first thing you need to know that an alternating what? Current source of EMF. AC what? AC source of EMF can be represented by what? By a circuit diagram. The AC source of EMF is represented by the circuit diagram. What? Diagram symbol. Diagram symbol. Look at this diagram symbol. Two extended line towards left and right with a circle inscribed into that circle like a sinusoidal sign. So this is what? This is an AC what? This is an AC source of what? EMF. An AC source of what? EMF. EMF. This is an AC source of EMF with voltage and what? Frequency. Angular what? Frequency. Right what? AC source of what? EMF with what? The voltage and the angular frequency. So this is what? This is symbol for what? This means that this is symbol. This is electric what? Symbol. Note this. This is the electrical symbol for what? For an alternating current source of what? EMF. Now, as we are talking about today, resistance and what? Reactance. The resistance and the reactance in an AC what? Circuit. We are talking about resistance. Resistance is what? As you know, is a result of what? The resistor. And resistance is an opposition to the what? To the flow of current. While also reactance is also an opposition of what? To the flow of current. But this reactance is made up of two. This resistance is from what? Resistor. While this reactance is from what? Is from the capacitor and the what? Inductor. Now, what do I mean by that is that this resistance and reactance are defined as the opposition measured in ohms to an alternating current caused by resistor and what? And capacitor. Caused by resistor, capacitor, and what? Inductor. So we are talking about what? Resistance now. Resistance is an opposition in ohms to an AC what? Current. To an AC current. That is to an alternating what? Current. To an AC current caused by what? By a resistor. Now, by a resistor. A resistance is what? Is the opposition in ohms to an AC current caused by what? A resistor. Why? Reactance, we are talking about reactance. It's also the what is the opposition in ohms. They are also measured in ohms. Or is the opposition in ohms to alternating what? To alternating current. To alternating current caused by either inductor, caused by what? Inductor, and what? Or caused by inductor or capacitor. Now, the reactance is the opposition in ohms to alternating what? Current caused by inductor and capacitor. So it means that we have resistance that is caused by the resistor and the reactance that is caused by what? The capacitor and the what? Inductor. Now let's go into this part. This, how do we draw the diagram when we have resistance in a what? In an AC circuit? How do we draw circuit when we have inductor in an AC what? An AC circuit? And how do we draw the circuit when we have what? When we have a capacitor in an AC circuit? And how do we draw what? An AC circuit when we have the what? The three combined in an AC circuit. Resistor in an AC circuit. Now, this is the symbol of what? Resistor. Connected to an alternative EMF or source. So we have our EMF here. Now, this EMF source produces an EMF E, which cause a potential difference to flow across this what? Across this what? Resistor. So the potential difference across this resistor is what called VR. And look at this, the potential difference PD, which is also denoted as VR, across the what? Across the resistor. Is in the same one, is in the same phase, with the current. This is very, very important. With the current. So we need that VR is equal to what? IR. V equals what? IR. But when you come to inductor in a what? In an AC what? In an AC circuit, an alternating current circuit. Now, when you look at this one, an inductor is represented by what? By a coily what? A coily what? Line. So this is an symbol for inductor. So connected to what? To an A what? To an AC source of what? Voltage. Now, when a voltage runs through this place, assuming we have what? This is the terminal of what? Of the what? Of the inductor. L represent L for what? And why the voltage will be what? V what? L. Why this one is what? This is our resistor. Now, this is the what? The inductor, and the voltage across the inductor is called VL. Now in this place, the voltage, the potential difference VL across what? Across the inductor. The potential difference across the inductor leads the current. This is the current by what? By 90 what degree. That is the alpha, based on the equation that we write together now, the alpha will be equal to plus 90 what degree. So in other words, the V here will be what? V naught sine W is okay cos W T plus what? 90 degrees. So that's what it means. It leads. Look at this. This is very, very important. The potential difference across the inductor leads the current by 90 degrees. So what the last one here is what? The last one here is the what? Is the last circuit, that is the capacitor. The capacitor in an AC what? In an AC circuit. The capacitor in an AC circuit. Now let me put it down here. The capacitor. Now the symbol for capacitor is what? Two equal lines. Now two equal lines is a capacitor. Now connected to what? A voltage what? a voltage, an AC voltage source. So here the potential difference here, which is capacitor what C, and the what this capacitor, and the voltage across the capacitor is known as what VC. V subscript what C, V subscript C. So the potential difference known as VC across the what? Across the capacitor, lacks the current, lacks the current by 90 degrees. That is with what? That is the alpha. The alpha now will be equal to what? Minus what? 90 degrees. So the equation here will just be what? V equal to V naught cos what? W what? T minus 90 degrees. It lags behind by what? 90 degrees. So and this 90 degrees can also be what? Equivalent to 90 degrees in radians will be what? Pi over what? 2. So whenever they are using what? Whenever they are using pi over 2, they are still what? They still set as 90 degrees. It's just that this is pi over 2 radian. The measurement here is a radian. So you can say the current lags behind by what? Pi over 2 radians. In what? In inductor in an AC circuit, the current what? Leads by 90 degrees, which is leads by pi over 2 radians. So that's that. Now this what? This voltage can be represented with the voltage in VR, the voltage in VR, that is the voltage in resistor, which is VR, and voltage in what? In inductor, which is VA, and the voltage in what? In capacitor, which is what? VC, can be represented by what? By a vector what? Diagram, represented by a vector diagram, which I will manage and draw here. Now, the vector diagram, diagram of what? Of the 3 voltage is what? Given as what? You have what? Now, here we have the what? The VL here. You have the VC here. The VC, that is what? The VC here. And we have the VR here. So when you bring this one out like this, when you trace it out, still draw it in another way. I just don't want to relate it here so that we can get something. So VL minus V what? C. And this one what? So this here is what? VL minus what? VC. So this one here is what? The right angle, and this one is what? The resultant V. So we have here VC, VR at this point. So when we want to find something like the vector diagram, what? The sum total of the what? Of the voltage, I will write it. Sum total of the what? Voltage. V what? VR, comma VC, and comma what? VL is now V squared equal to what? VR squared. This is Pythagoras theorem from that place, plus open bracket VL minus what? VC, all what? Squared. So in other words, now you have to calculate what? The voltage. So the voltage is now what? Equal to what? Square root of V R squared minus what? VL, okay, plus VL minus VC, all what? Squared. This is very, very what? Crucial. The formula here is very, very what? Crucial. So that's that about that. About the dependence, which is dependence hour. The dependence is the what? Is the sum total of opposition. Dependence is the sum total of opposition. Dependence is the sum total of oppositions in ohms. Cost is the sum total of opposition in ohms to AC what? Current, that is the alternating current. Cost by resistor, caused by resistor, inductor, and what? And caused by resistor, inductor, and capacitor. So caused by what? Or the sum total of evolution in ohms to AC what? AC current caused by the resistor, the inductor, and the capacitor all at the same time. So now this mathematically we use what Z to denote impedance, and recall that V equals what? Recall that V equal to VR squared plus what? VL minus what? VC all squared. You know that in what? In series connection, we usually have what? The same what? The same current. So when you factorize what? The current out. When you factorize the current out, rest down now. The VR is what? The voltage VR is calculated as what? IR. The VL is calculated as what? I multiplied by what? XL. XL and what? And I will still tell us what XL represents. And VC is obtained as what? I what? XC. So these are the formula for obtaining what? VR. VR is equal to IR. VR is what? IS subscript N. VC is what? IX subscript C. So when you substitute this inside this place, you are going to have what? When you substitute this IR and this SIXL and this inside this place, you are going to have what? I square, R square, and so on and so forth. When you factorize it, you are going to have V equal to what? Square root of I square into bracket VR plus what? Plus open bracket what? VL minus VC bracket close. Now this one, when you close the bracket, then this one square V. So you can now find the square root of this I square. So you have V equal to what? I. V equals I square root of what? Square root of, so you are going to, when you place this one together, you are going to have, when you start of import, putting now V equals IR, VR equals IR, VL equal to ISL, this is equal to what? IXC. Now when we put this inside this now, you're going to have what? V equal to what? V equal to, look at this, when you look at this very well, you will see you are going to get what? I into bracket, because of my time, I square equal to what? This one will be VR, so we are going to have R squared left plus what? Open bracket, another bracket, you are going to have what? XL minus what? XC left. So big bracket what? So big bracket now. So everything was outside. So this one will be V. When you find the square root of this one will be VI square root of what? R squared plus what? XC XL minus SC or what? Squared. So that's what we have left in the bracket now. So V over I now be equal to what? R squared plus XL minus XC or what? Squared. Meaning that what? Impedance, this impedance Z equals to what? VI, where Z is equal to V over what? I, known as impedance. So impedance is now given as Z equal to square root of what? R squared plus what? XL minus XC. XL minus XC or square. This is how to calculate what? The impedance, which is sum total of the what? Now, where XL is the what? XL is the what? When XL is equal to what? Is what? Is the what? Where XL is equal to 2, which L is equal to, when XL is equal to WL, which is same as what? This is what? Angular frequency 2 per Hz. We can replace as 2 per Hz. We call this one The formula for this, we call it what? Capacitive, the what? The SL equal to WL equal to 2 pi FL is known as what? The inductive what? The inductive reactance. The inductive reactance. Why the XC is given as what? 1 over WL. 1 over WC rather. 1 over WC. So X is equal to 1 over what? WC, which is equal to 1 over 2 pi F what? C. Was 1 over 2 pi FC. So, which is also known as what? The capacitive what? The capacitive induct reactance. The capacitive what? Reactance. Also measure in what? They are all measured what? Both are measured in what? So, this is what? SL, the inductive reactance, and this is what? SC, the capacitive what? Reactance. You still know about that as what? And going to what? Into calculation. So lastly, let's talk about the what? That is what? Introduction. Let's talk about the resonance what? The resonance what? Or resonance frequency. Or resonance. Now, resonance is the frequency where we have what? The what? The current to have its maximum what? Value. Resonance frequency is the what? Is the frequency. Is a frequency. Is the frequency where the current has its maximum what? Value. The frequency where the frequency where the current has its maximum value is what we call resonance. It's the frequency where the current has its what? Maximum value. And at this frequency, XL at this very XL is equal to what? X what? C. SL is equal to X, that is the what? The inductive what? That is the inductive reactance is equal to what? The capacitance what? The capacitive reactance. So they are equal. So in other words, so we now have what? If XL is 2 pi FL, and this one is what? 2. This one is 1 over 2 pi F what? We call that this is what? This is WL, and this is what? 1 over W what? C. So 1 over WC what? Omega is 2 pi FL. Now WC will become now 2 pi FC. So this 2 pi F what? C, this 2 pi FL. So naming this what? This L now our resonant frequency not. So I can that is resonant frequency. So by cross multiplication now. So when cross multiply you have what? 2 pi F naught. Now this one will carry square and square. Only L and C does not carry. When you multiply that's 2 times 2 got 2 square. 5 times 5 will be pi square. F times F will be F naught square equal to 1. Taking the square root of both sides. Take the square root of, so you have what? You have 2 square pi square F naught square. Now when you take the square root of both sides, what do you have? When you take the square root of both sides, we have what? Square root of both sides, we have square root of both sides. Definitely we are going to have 2 because these 2 cancel square root. So we have 2, we have what? Pi, we have F naught. But this one cannot cancel, I have the square root of L what? C. And the square root of 1 is also what? 1. So divide both sides by what? Divide both sides by 2 pi root FC to make this solid formula, to make regular frequency formula. Okay, we have 2 pi root L what? C. So cancel this one, cancel this and this. So F naught, which is our resonant frequency, is equal to 1 over 2 pi root L what? C. So this is the formula for calculating what? This is the formula for calculating resonance what? Frequency. Now, having done this, now let's go into our let's go to what solving the problem before us, as we know the formula to apply now. So let's look at into the calculations before us and apply those formulas. This question before us says that divide the reactance and what dependence. I told you that reactance is divide, and we have to divide it. The first question is what? Divide what? Reactance. Now, reactance is what? Is the opposition. Reactance is the opposition. Is the opposition in ohm. Measured in ohm. Is the opposition measured in what? In ohms. To what? In ohms to an AC what? AC current caused by what? The reactance can be caused by a capacitor or inductor, or both at the same what? Or both at the same time. It is when combined together at the same time. So this is reactance. The opposition in both an AC circuit caused by a capacitor or inductor, or both at the same what? Time. Now, explain the resonant frequency. I just did that now. Resonant frequency is the frequency where what? Is the frequency that is the frequency where I is what? Where I is maximum. So it didn't let me just rest. So it's the frequency where what? I is maximum. So the formula for resonant frequency mathematically now is equal to what? 2 pi root what? LC. If you don't know the what, if you don't know the definition, you can go right to what? The formula. You are going to have a full mark. Now, formula figure 2, we talk about what? Impedance Z. Impedance Z is what? Is the sum total. Is the sum total of the opposition in an error. Is the sum total. Is the sum total. Is the sum total of opposition or towards innovation in ohms to AC current, to AC current, to AC current, to alternating current in RLC circuits, or caused by RLC, caused by what we can say is the opposition, the same sum total of opposition in ohms to AC current in an RLC circuit. In a house, the sum total of opposition in ohms to an AC current in RLC circuit, that is caused by what? RLC, caused by RLC in a circuit, or you can define it in any form, just where we have a resistor, inductor, and what? And capacitor. So in the delta form, you can say is the sum total of opposition in ohms to an AC current caused by resistor, inductor, and what? And capacitor in the circuit. Caused by what? What? RL, inductor, and what? Capacitor. So impedance is given as what? Square root of what? R squared plus SL minus SC. So that's the mathematical expression. So now we have to explain the statement. The power supply voltage of a source is what? 230 volts. Power supply of what? This is just what? He's saying the power supply what? That is the root means square. The root means square voltage of the root means square voltage of AC power supply is 230 volts. So because it says power supply voltage, that is, we said that what an AC current possesses what? Higher voltage, which helps them to supply what? To supply current at long what? Distance. So the root square velocity voltage of AC power supply is what? 230 volts. So that's how to interpret it. Now number C, to jump to number C, straightforward, which is the calculation aspect of it. Look at this very carefully. I'm going to A source of what? A source of EMF 240 volts and frequency 50 watts acts. A source of EMF 240 volts and frequency 50 watts acts is connected in series arrangement of a resistor, inductor, and capacitor. Now, can we interpret that one first? A source of EMF 240 volts and frequency what? So, a source of EMF what? So, an alternating current of EMF is what? That is 240 volts. We put it here, comma, frequency 50 watts. Arcs. So that's the frequency. Is connected to what? Is connected in series arrangement of a resistor. So always remember to draw the diagram. Even if they didn't ask you, draw the diagram to represent the what? Connected to a series, side by side, side by side to a resistor. The symbol of resistor is what? This. Then this is resistor. We have inductor. Then we have what? And the capacitor. They are all in series. So now they connect it in series. Now when the current in a capacitor is 10 ohm, don't forget the current that flows through a capacitor, and don't forget that the current are the same. The current that flows here is the same all through. So the current flow through a capacitor, you can use the symbol of what? 10 ampere flows, or you can use arrow, flows. So through what? This current flow 10 ampere flows through what? Capacitor. The potential difference across the resistor is what? The potential difference across the resistor. Let me just separate this. Is 140 volts. So, and that across the inductor. That's across the inductor is what? 50 volts. Let's use dash line. So now calculate the potential difference across the what? Across the capacitor. So the potential difference across the capacitor, let's represent it with VC, which we don't know. VC, which we don't know. So how do we go about it? No, we talk about the what? The relationship between the what? The relationship between the what? The VR, VC, and the what? And the VL is given as well this. So can we write this formula how? V squared is V squared equal to VR squared plus what? VL minus what? VC or what? Squared. So when substitute now, this is 240 squared equal to VR squared is what? The what? This is the VR here, this is the VL, and this is VC. VR is 140 squared plus VL, which is what? 50 minus VC all squared. So when you transfer this to the other side, you have what? Transfer this to, we have 240 squared minus 140 squared equal to V minus VC what? Squared. So this one will give you what? And minus this square, you press your calculator. So what do you have? You press your calculator. What do you have? Must you not use your calculator? So you press your calculator here. You have what? 240 square. 240 square minus 140 square. So you have 38,000. 38 what? 38,000 equal to what? Equal to 50 minus V6 or what? Square. You have to take the square root of what? Take what? The square root of both sides. So you have square root of what? 38 what? 1,000 equal to 50 minus what? VC or what? Square. We take the square root of this also. Look at this. This is 50 now. So square root cancel square. So what is the square root? Square root answer. We have 194.93 equal to 50 minus VC. So now this is VC. Take this one to the Other side, take this one to the other side, this 50, so this will be 194 minus what? 2 minus 90 what? 194.93 minus 50 equals what? V what? V what? C. So 190, when I take this 50, this also we have what? Let's look at it. This will be, take this one, this will be 194.93 minus what? 50 equals what? Minus V what? C. So 194 minus what? 50 here. This is what? 190 what? 194.93 minus what? 50. It's giving what? 144.93 equals to minus VC. So this minus VC just shows that this minus VC just indicate that this thing is at the lower what is as what at the minor negative what y axis in the vector diagram. When I draw the vector diagram, I have VL on the top, VC below, which is a negative part. So this is what your VC now is equal to 144.93 volts. So that's that about that. Now let's move to the next question. That's what we are told that you calculate the number 2, the capacitance of the capacitor. Calculate the capacitance of the what? The capacitor. The capacitance of the capacitor. Now, when I talk about the capacitance of the capacitor, it's different from the capacitive reactance. So you have to know what you are about to calculate for. The capacitance so you have to calculate what let's see. So let's see we have to go to the capacitance of the which means you have to calculate C. Capacitance of the capacitor C. And how do we get C? The first thing is to know that XC is equal to 1 over what? 2 by F. Then this is the C that we have to calculate. The first thing is to get your XC. And you know that your VC is equal to IXC. So they are giving you the current, which is 10 ohms. So you have what? XC now equals to what? VC over IC. They are current passing through the capacitor, but not that the same current passes through. So that's why I didn't put C here. So VC is equal to over I is what? 144.93 divided by what? 10. So we have 14.493 ohms. The VC is IC is what is in ohms. So we now equate this one as this was 14.493 equals 1 over. Now what is your 2 pi? 2 times 3.14 times. What is your F? F is what? 50 hours. So that is your F. What is 50 hours? So 2 pi F 50 hours times C, which you are looking for. When you multiply this now, and you divide it, what do you have? So cross multiply, what do you have now? Cross multiply, you have what? This times this, what do you have? You have what? 114.493 multiply by 2, multiply by 3.14, multiply by 50. So multiply by 50 is equal to what? We have what? 450.8 C equals to 1. So when you divide 550.802 over 455.802. So what do you have? What's your C? C will be equal to what? 1 divided by that side here. To what? 0.000219. So you have to make this one in what? A microfarad now. It was in Faraday. Now this is what this 1, 2, 3 are. So I can decide to leave it in millifarad. or in microfarad. So if I want to do it this one in microfarad, 1, 2, 3, 4, 5, 6. I don't want that, it's too big. So let me do it as milli. 1, 2, 3. So I'm having what C equal to 0.219 multiplied by, or let me make it in standard form. Okay, 1, 2, 3. So that is C equal to what? 0.00. Okay, listen to me. Now we have something like this. We have C equal to 0.0000219, and so on and so forth. So let's make this one in what? In millifarad, because the unit here is farad. So if I want to make it millifarad, I will do 1, 2, 3. So it will be 0.2197 milliwatt farad. So that's that about that. So that's that about that. So let's move to the what? To the next question. Next question says the inductance of the inductor. The inductance of the inductor. So how do you get the inductance of the inductor? So I know that for the VL is 50. Look at from that guy, I have VL. That's I think the VL is what? 50 volts. The VL is what? 50 volts. Then the current that we know that is flowing through the VL, we know that VL is what? 50, it is 50 volts. Do you have any other information about what? So do you have other information, any other information about the inductor? No. So we can easily get what? The I is the same thing. The I is the same thing, which is 10 ampere. So if the I is 10 ampere, then we have what? You can calculate for VL. So we know VL is equal to I XL. So XL equals what? V over what? I. So we have what? 50 over 10. We have XL equals what? What's XL? So we have what? XL is equal to 5 what? Oh, so with 5 ohms now we can get our what? We can get our XL. And how do we get our XL? XL is equal to what? XL is equal to 2 pi F what? L. So meaning that 55 is equal to what? 2 times 3.14 multiplied by 50. Because 50 multiplied by what? L. So once you multiply this one now, L will now be equal to 5 all over. Now, divide both sides by what? Divide both sides by this. 2 times 3.14 times 50. We have 5 divided by open bracket 2 times what? 3.14 multiplied by 50. To save your time, you just do like that. So what do we have now? We have a 0.01592. So this is 0.1592. So that is Henry. The inductance now. The inductor is what? Henry. The unit is Henry. So that's that about that Henry. So the last one says draw and label one vector diagram for the what? Potential difference across the inductor. Draw what? Vector diagram to what? For the what? For the potential difference across the inductor, capacitor and resistor in C. Now the vector diagram is just, we have done it before, let me draw it again. The vector diagram for this now, the vector diagram now the what? The vector diagram which is what? D is what? We draw it like this. The VL, the VC, and the V what are. So we have this extending out, so that is VL minus what? VC. So this is the vector that I have to draw. So that's that about question number what? 1. Now let's go to question number 2.